What's going on, everybody? Got another video for you. This is a trig video. Product to sum and sum to product identities, and we're going to look at reduction formula. So let's get started. Shouldn't be too long of a video. Shouldn't be that bad. All right, so here we got our product to sum identity. So it's not difficult. Basically, it's just plugging stuff into formulas. You just got to memorize the formulas unless you have a nice teacher and they don't make you memorize the formula and give you a formula sheet. So, All right, so let's look at this. So basically what it is if you have two trig functions, like sine and cosine, and they're multiplied together, and notice that what we have here, the angles are different. See, sine A, cosine B. See how the angles are different? Well, what we can do is we can write this as a sum. So I'm not going to read through the formulas. You can look at them, but basically on the first one, sine A plus cosine B is equal to 1/2 times sine A plus B. You add the two angles plus sine A minus B, this angle minus this angle. And then the other formulas are similar. So let's look at some examples. And these first two examples here is basically just use the formula to rewrite it. Just practice rewriting it. So use the product to sum identities to rewrite each expression. So notice what we have here. We have sine, cosine. Okay. We've got sine A, cosine B. See, we've got this first formula. Let me pull this down some. We got this first formula right here. That's the one we're going to use. See, we got sine A, cosine B. So in this case, A is 12 and B is 9. And so this is going to equal 1/2 sine A plus B, so that's 12 plus 9, plus sine 12 minus 9. And so this is going to give us 1/2, and that's going to be sine 21 degrees plus sine of 3 degrees. And that's all they're wanting us to do. Okay. All right, let's look at the next one. We've got sine pi over 12 times sine pi over 8. So that's going to be this one, sine pi over 12 times sine pi over 8. So we're going to use this formula. So this is going to equal 1/2, and it's going to be what? It's going to be cosine of A minus B. So that's pi over 12 minus pi over 8 minus cosine pi over 12 plus pi over 8. And that's all there is to it. And so this is going to be 1/2, and that's going to be cosine. And then we have pi over 12 minus pi over 8 is negative pi over 24 minus cosine of, that's going to be 5 pi over 24. And then notice here how we got the negative in here. So let's write that as 1/2, and we're going to use our negative angle identity. Remember, you have a negative angle identity that says cosine of negative theta is equal to cosine. Is equal to cosine theta. So we're going to rewrite this as cosine of pi over 24 minus cosine of 5 pi over 24. And there's your answer. Now, your question might be, how did you get negative pi over 24 and 5 pi over 24? Well, remember, we're doing pi over 12 minus pi over 8. So we're going to get a common denominator of 24. What do we multiply to the 12 to get 24? 2. So we got to multiply 2 to the numerator. And then what do we multiply to 8 to get 24? 3. So we got to multiply 3 to the numerator. And so 2 pi minus 3 pi is negative pi over 24. And then if you're adding them, say, look, if we have the addition in between them, then you can see that would be 2 pi plus 3 pi is 5 pi over 24. So that's how you get those. And this is your answer right here. All right. All right, here they want us to use a product to sum identity to find the exact value. All right, so what are we going to use? Well, we're going to use, and let's just write the formula down. We've got cosine A times sine B is equal to 1/2, and that's going to be sine A plus B minus sine A minus B. So we got cosine A sine B. Cosine A sine B. This is the formula we're using. I just wrote it down here so we could see it. All right, so once again, there's A, there's B. So we've got cosine 67.5. Let me put the degree symbol. 67.5 degrees times sine of 112.5 degrees. That's going to be 1/2 times the sine of 67.5 plus 112.5 minus sine 67.5 minus 112.5. All right. And so this is going to give us 1/2 times the sine of 180 minus the sine of negative 45. All right. And once again, we got a negative in here. See the negative 45? So we're going to use a negative angle identity that says the sine of negative theta is equal to negative sine theta. So this is going to be 1/2 sine of 180. And then if that's negative sine, the negative and negative make a positive sine of 45 degrees. And so this is equal to 1/2 times. Now, here's the big question. What's the sine of 180? Well, we all know that's 0. Plus the sine of 45 is square root of 2 over 2. Oh, but how did you get that? How did you know 0 and square root of 2 over 2? That's the ones you've got to memorize. You've got to know those special angles. And so this is going to be 1/2 times the square root of 2 over 2, which is square root of 2 over 4. And there's your answer. See, it's not bad. You just got to go use the correct formula, use it, and plug numbers in. Just like you were in 3rd, 4th, 5th grade. Same thing. Just plugging numbers in. All right, now we've got sum to product identities. And it's similar to what we just did. It's just the formulas are different. We're doing the same thing. So we'll look at the first one. So sine x plus sine y is 2 times sine of x plus y over 2 times cosine of x minus y over 2. And then the other ones, they're similar. Once again, you just got to know the formulas, unless you have a nice teacher and they say, hey, you can use a formula sheet for the test. And so if you're one of my students watching the video and you might be thinking to yourself, is he going to let us use a formula sheet? Yes, I will. All right. So let's see what we've got here. All right, we've got sine 8 degrees plus sine of 6 degrees. Okay. So which one are we going to use? Well, that's the first one. See, sine plus sine, sine plus sine. So this is going to be 2 times the sine. Now, look at this. In this problem, this is x and this is our y. So that's the sine of 8 degrees plus 6 degrees over 2 times cosine of 8 degrees plus 6 degrees over, oh, I'm sorry. Why am I adding? 8 degrees minus 6 degrees over 2. All right, so now we get what? We get 2 sine of 8 plus 6 is 14. 14 divided by 2 is 7. And then cosine of 8 minus 6 is 2. 2 divided by 2 is 1. And there's your answer. All right, let's look at another one. We've got cosine minus cosine. It's this bottom one, cosine minus cosine. See, here's x, here's y. And so this is going to be 2 times sine. That's going to be pi over 5 plus pi over 8 divided by 2. And then that's going to be sine of pi over 5 minus pi over 8 divided by 2. All right. So this is going to be 2 times the sine of 13 pi over 80 times sine of 3 pi over 80. And this is your answer. And don't worry, I'm going to show you how we got that. Okay? So there's a couple of ways you can do this. I'm going to show you the easiest way to do it. So let's just come up here and do it. We got pi over 5 plus pi over 8 over 2. All right, so how do we get that? Well, this is just a complex fraction. So you can look at this 2 as being over 1. And what we do is we look at each one of these denominators, the 1, the 5, and the 8. And we get a common denominator, and the common denominator is 40. So we're going to multiply each term by 40. And so that's going to give us, well, look at this. The 40 and the 5 cancel, we're left with 8. The 8 and the 40 cancel, we're left with 5. And so this is going to be 8 pi plus 5 pi over, and 40 times 2 is 80. And 8 pi, or 40 times 2 is 80. 8 pi plus 5 pi is 13 pi over 80. And that's where the 13 pi over 80 comes from. And then this one, the other one would be similar. Okay, I'll leave that one for you to practice. All right, so what about this one? Well, this is your x, this is your y. We've got sine x minus sine y. So that's this one. You see that? That's this one. So this is going to give us, and I'm not going to worry about writing the formula down. That's going to be, you can here, sine x minus sine y. There it is. Write it down so you can see it. Pause the video and write it. All right, so that's going to be 2 times cosine 6t minus 4t over 2 times sine of 6t minus 4t over 2, and that should be a plus, not a minus. Okay. So just remember, I mean, when you're doing this, the first ones are all adding, the second ones are all subtracting. Don't make the mistake I did just then. And so this is 2 times cosine of, well, 6t plus 4t is 10t divided by 2 is 5t. And then 6t minus 4t is 2t. 2t divided by 2 is just t. So sine t. And there's your answer. All right. So let's look at this one. Use a sum to product identity to find the exact value. So I've got cosine plus cosine. That is this formula. So write it down so you can look at it while we're working the problem. Okay. Cosine plus cosine. So there's your x and there's your y. So that is going to be 2 times cosine of 112.5 plus 67.5 over 2 times cosine 112.5 minus 67.5 over 2. And so this is going to be 2 times cosine, and that you can plug it in your calculator. That's 180 over 2, which is 90, times cosine of, and I believe that's going to be 45 over 90, so that's 22.5. All right, so they want us to find the exact value. Now, let's think about this for a second. We actually got lucky on this problem because this is just 0, okay? And how do we know that? See, I don't care what this is, and I don't care about the 2. All I know is I know cosine of 90 degrees is 0. So 0 times whatever those are just 0. But what if that was not 0? How would we solve for cosine 22.5? Because there's the magic word there, exact value. Well, to do that one, we would do what? We would do cosine of 45 over 2, right? Half angle identity. Isn't 22.5 45 divided by 2? And that would be the square root of what? 1 plus cosine 45 degrees over 2. You would use that formula to calculate that, but we don't need to because this one right here is 0, so that just makes the whole thing 0. But if it wasn't, if this was not 0, then you would need to do this to find that exact value. Okay? All right. Now, let's look at this reduction formula. So if alpha is an angle in standard position whose terminal side contains AB, do we remember what standard position is? So remember, standard position is an angle whose initial side, this one, lies along the positive x-axis and it rotates in a counterclockwise direction. It has, here's your rotation theta. And the vertex is at the origin. That's an angle in standard position. Okay, just a refresher, you learned that at the very beginning of trig. Then a sine x plus b cosine x is equal to the square root of a squared plus b squared times sine of x plus alpha for any real number x. All right, so let's do some examples working that. It says use the reduction formula to rewrite -3 sine x minus 3 cosine x in the form a sine x plus c. So basically what we're doing is we have a sum of, we have multiple trig functions and we're writing it as a single trig function, a phase shifted trig function. All right, so let's look at this. So in this problem, we can see that a is equal to -3 and b is equal to -3. So what all do we need to find? Well, we need to know what alpha is, don't we? See, we need alpha and we need the number in front here. Okay. All right. So let's see what we get here. So we've got the square root of -3 squared plus -3 squared. I'm getting the number in front here. This is actually our A in this problem. You see that, our capital A? That's equal to the square root of 9 plus 9, which is the square root of 18, which is 3 square roots of 2. So that's our number in front of sign here. And now we need to get alpha, which they're calling C in this problem. Well, if you look at this, if we plot the point, okay, if we plot the point, -3, -3, because see, it says the point AB, that's your point AB. That is right here. That's a point right there. And we need this angle here. This is -3, -3. All right, so there's a couple of ways we can find this. We can use the fact that, see, we'll call this alpha, our angle right here. So we could use the fact that cosine alpha is equal to what? Now remember, this A, that's considered your X, Y coordinate, right? I don't want to put, I'm going to erase the X and Y because I don't want you to get it confused with this X or this X. But it's like your X, Y coordinate. We go to the left, -3, and down -3. Or we would go to the left 3 and down 3. So remember cosine is X over R. And look, you see this right here where we did this square root of A squared plus B squared? Well, that's, you can also look at that as R, right? See, if that's R, isn't it A squared plus B squared? The square root of that? Okay, so you could actually find this as -3, which is our X, over 3 square root of 2, which this is -1 over square root of 2, which is negative square root of 2 over 2. You could also look at it as tangent alpha is equal to -3 over -3, which is 1. Okay, so, you know, because remember, tangent is Y over X. So you can look at it either way. It doesn't matter. Okay, you're going to get the same answer anyway. Now, look at this. The tangent one, that might confuse you. Tangent, because you look at, oh, tangent alpha is 1. Well, what would that be? We might get the impression that alpha is pi over 4, right? Because the tangent of 45 is 1. You might get that impression. But notice when we plot the point, we're over here. This right here, this pi over 4 is a reference. It's going to be considered a reference angle. Okay? A reference angle. So this angle right here is pi over 4. And so to get alpha, alpha is going to be pi plus pi over 4, which is 5 pi over 4, right? Because we got to go to pi and then 4 pi more. So what's our solution? Well, so that means we've got -3 sine x minus 3 cosine x is equal to, so it's equal to this, which is 3 square root of 2 times the sine of x, what? X plus alpha. So plus 5 pi over 4. And this would be your answer right here. All right. Now, let me ask you this. Where would this come in handy? Well, I'm glad you asked that. Let's look at the next problem. All right. Graph one cycle of the function. You want to graph that? Well, we could. But how about we just write it? We write it as a sine function using this reduction formula and then graph it, because that would be much easier. Just think about this problem. Would you rather graph this one or this one? This one would be easier, wouldn't it? All right. So let's look at this. So we have a is equal to the square root of 3, b is equal to 1. And so now keep in mind, we're going to write this as y equals a sine x plus c. We'll just use the same notation that they used here, okay? And just keep in mind, when they're using this notation here, this right here is your capital A, and this is what they're referring to as C, okay? Just different variables they're using, that's it. And so we get a is equal to the square root of 3 squared plus 1 squared, and that is what? I believe that's 2. Okay, they gave us a nice number there. All right, so now let's look at let's look and see what we've got here. So how can we go about finding alpha? Well, let's just look at the different ways. You only have to use one. We can use sine alpha is equal to what? Y over r, right? Remember, this is considered x, this is considered your y, and this is your r, okay? So y over r, or you could use cosine alpha equals x over r, or you could use tangent alpha equals y over x, 1 over square root of 3, which is square root of 3 over 3. Either one's going to give you the correct answer, okay? Just pick one. So if we do this one, this gives us alpha is equal to pi over 6, right? This would be the sine of 30 degrees is 1/2. So alpha would be pi over 6. Now let's make sure we're in the correct quadrant, because remember over here, when we used the tangent, we got pi over 4, but we realized, hey, we're in the third quadrant, so we had to use this as a reference angle to get our third quadrant angle. But now this one, if we plot this point, let's plot that point. That's square root of 3, so that moves to the right, and the y coordinate is 1. Oh, so look at that. We are in the correct quadrant. So we can write this as y equals 2 sine of x plus pi over 6. And now look at this. Instead of graphing this, we can just graph this. So let's do that. Now, if you're at this point in trig, then you know how to graph already. Okay? So I'm going to go through this next part kind of quick. If you need to refresh yourself on graphing, go watch my videos on graphing. They should be in the trig playlist, or just search my channel, Trigonometry, graphing, trig functions, or something like that, and they should pop up. Probably 2 separate videos. One video is probably sine and cosine, the other video is probably the other ones, the other trig functions. So let's just look at this. I don't know how many teachers show the graph like I do, but I think this is the best way to do it. All right, so we need to know what period we need to graph it over. So whatever you're taking the sine or cosine of, you're going to put that between 0 and 2 pi. And then you're going to solve for x. So I'm going to subtract pi over 6 to both sides. And so that's going to give me negative pi over 6 is less than or equal to x, less than or equal to, that's 2 pi, which would be, if we put that over 6, that would be 12 pi over 6 minus pi over 6 is 11 pi over 6. So that's what we're going to graph it over. So we've got negative pi over 6, and we've got 11 pi. We've got 11 pi over 6. All right, so now what we want to do is split this up into 4 equal intervals. So we need the midpoint between negative pi over 6 and 11 pi over 6. So how do we do that? When we come over here, we've got negative pi over 6 plus 11 pi over 6, and that is 10 pi over 6, which is 5 pi over 3. All right, and then we take the 5 pi over 3 and half it, and that's going to give us 5 pi over 6. And so this would be 5 pi over 6. That's how you find the midpoint between two values. Okay, to find the midpoint between two values, you add them up and then multiply by a half. And so then I would get the midpoint here would be, I believe that's going to be pi over 3. Pi over 3, because this would be what, 4 pi over 6, which is 2 pi over 3 times a half. 2 pi over 3 times a half is just pi over 3. And then this one would be, I believe that's going to be 4 pi over 3. That's going to be 16 pi over 6. See, 5 pi over 6 plus 11 pi over 6 is 16 pi over 6, which that's going to be 8 pi over 3. And then times a half, that's 4. That's going to be 4 pi over 3. That's right. Okay. And now we need to put our y. Look at that. That'd be pi over 3. I don't know why I put pi over pi. I lost my mind. All right. So the 0, that's going to be the y-axis where x is 0. That's going to be about right in here. Okay. Now, do we remember how the sine function goes? So what's our amplitude, our largest and smallest value? That's going to be -2 and 2, right? The 2 in front. So remember, sine starts at 0, then it goes to a maximum, then it goes back to a 0, and then it goes to a minimum, and then back to 0. Like I said, if you're having trouble with the graphing thing here, you can go watch my videos on that. But there's your graph there. There's one cycle of it. And now for this let's just state the period. The period, remember, the period is 2 pi over b, which that's the number in front of the x value. So that's going to be 2 pi over 1, which is 2 pi. So there's your period. And then what do we want? Let's do the amplitude. Amplitude, that's the number in front. Where's my function? Here's my function here. So that's going to be 2. Okay, we got the number in front there. And then the phase shift. Okay. So the phase shift, remember the phase shift, you can do -c over b. Okay. But look, if you do this like I showed you, this right here, setting up that inequality, and once you solve it for x, this right here is your phase shift, -pi over 6. Okay. All right. So, it made it a lot easier writing this as just a single sine function and then graphing it. All right. So I hope that video helped you. Hope you learned a lot, and hopefully you feel smarter. So appreciate you watching. Check out my other videos. Give me a like, share, subscribe, and comment, and I will see y'all in the next one. Later.